Okay, this is part 3 of the review. So, in the interest of time, I will skip the problem 4. But I want to mention that I would like to make the correction here. So, after this correction, so where we use use the last element as our pivot value, okay, and then only swap if I is not equal to j. Then it's the exact same code we have gone through in class. So I'll prioritize review of other problem for now. So this one. Okay, right. Is the above imputation of quicksort stable? Yes, right. I will not require you to answer the second part, but the first part is discussed in class. Okay, number 5, merge sort. In this question, you are asked to carry out the algorithm on the following input. Part A, illustrate how it works by drawing out all recursive calls. Okay. And write out the content array when each call returns. So let's do that. So this is also in homework 2. So I will not repeat this review in homework 2. So I'm going to start. Okay. So I will call my function ms, right, to save time. So the first ever call to merge sort is when we pass array as our parameter and pass a left end, which is 0, and right end index as our parameter. Okay, so let me mark it here. So here we assume the index start from, okay, something's wrong here. All right, so it should be 5. Okay, 0, 1, 2, 3, 4, 5, 6. Oh, actually 6. What I'm doing. All right, okay. All right, let's read back. All right, so you should remember what happened. Right, so a calculation of the midpoint first in the recursive function. So left plus right divided by 2, so it will be 3. Okay, and then what happens is that we try to call the function itself, but with the first time we're going to try to merge the left half, which is start from the left to the middle point, so 0 to 3. And the second call, we'll try to sort the second half of the array, which is A, from mid plus 1, that would be 4 and 6. Okay. Oh. Okay. So let's look at this function call, right? So in reality, we know this function will call this one, and then this one will call another function. So this will not happen until this function return back to the function that in the top. But we like to draw it in the level by level manner so we don't get confused. Okay, so for this function call, left is 0, right is 3. So the mid will be 0 plus 3 divided by 2, that will be 1. Okay, so the left half will be start from 0 to 1. The right half will be from 2 to 3. Correct? Okay, so for this one, we're not in the base case yet because left is not equal to right. So we still have more than one element. So we find the middle point, right? Mid will still be 0 plus 1 divided by 2 will be 0. So the left half will be A 0, 0. The right half start from mid plus 1 is 1, 1. Okay, so these two function calls, right, will be the base case, right? We have finally reached the base where the left equal to the right. So nothing will be done here, so they will just return, okay? All right, so back to this function, all right? So I'm going to use this space here to draw, right? So in this function call, what happens is that we are mainly looking at trying to merge sort this part, right? This part of the array, and the left half already sorted, okay? The right half already sorted, so we're in the merging part. So I'm going to showcase what happened in the merge part for this part, right? So we compare the first element in the first half, first element in the right half. So this one is smaller, so we put in the staging area, all right? And then this second half is pretty much done, so we copy remaining element in the first half over, so which will be 24. Okay, so now all the elements are copied to the staging area in sorted order. So what happened next is just copy them back to array A. All right, so array A, upon return, should have this content, right? 26. 54. So I'm going to mark here, right? So when this return, the content of the array has been changed, right? So the first two elements has put into order. Okay, so this kind of, I'm hoping by just showing this part, you will understand the whole thing. So when you work on this problem in your midterm, you're expected to complete the whole thing, all right, to finally show what will be the array contents when this function finally returns. So I wanted to showcase everything. So hopefully I'll give you a smaller problem to work on. All right, so that's this question, part A. So is the recursive merge sort algorithm stable? So the short answer is yes. Okay. It is stable. And the reason is really in the detail, like we have discussed, right? So in merging two sorted array, so we have using this formula, right? So the left half right, yeah, but I think we can just let it be. Okay, so it's important to remember the detail matter. If okay, so this part, the second question, I think is relatively simple, right? Is this merge algorithm, or is this sorting algorithm in place or out of place, right? It is, it's out of place, right? Because we use an array, right? Or list, or it can be a vector B when two sorted half are merged together. So, and also, you know, the size of B has to be the same as the length of A. So therefore the total space required is actually linear in the input size. Okay, so it's not in place, it is out of place. Finally, let's look at question number 6. Right. Okay, so actually this question we have looked at it in different time, sometimes as a quiz, sometimes as a homework, I believe. So the question is how to write a code to decide whether a list contains duplicate values or not. So it's true or false kind of output, right? So, okay. So, yeah. So let's look at the first part of the question. Write a pseudocode to solve the problem in brute force manner. So that means we don't care that much about efficiency. We just solved it most straightforward way. Okay. So what I want to do is I want to draw the input, okay, for you to visualize, and hopefully after have the drawing out, you will know, you will be able to identify which coding pattern we can use here, right? So please refer to page 1 in midterm review. Okay, so fill in with the value from the example here. Okay, so it doesn't matter what we have, right? So in order to test whether have duplicate or not, fundamentally we need to compare every number with every other number. Okay, right? So it's like the first number need to be compared with the second, third, fourth, all the way to the last. All right. So pairwise comparison. Likewise, if I look at the second number, oh, funny. All right. So I'm going to use a different color, right? So the second number has to be compared with everything that follow it, right, all the way to the last one. So which pattern to use, right? That's the pattern where we need to enumerate all the possible pairs. So, all right, so this is, I'm going to give the code here, right? So, so has duplicate or not. So this is my function header. And I'm going to use, so the first parameter is array itself, and then the left, right index. So what we're going to do is going to say, hey, for every number from left to second last one, I need to compare with everything follow it. So I is the first number we're looking at, J will be the second, the number we're going to compare it with. So J will start from I plus 1 to left. So we compare with this pair AI and J same, right? If it's same, then we can just return right away, right? Because we just discovered a pair of duplicate number. So, but if we go through the whole thing without returning, that means we don't have duplicate. So that's the code. So we should know that the worst case running time should be projected. Okay. So detail is omitted, right? But I expect you to be able to do that by unraveling the nested for loop, right? So I will start from, say, left, which is 0, right? And then go to 1 all the way to n minus 1, the second last. So for this iteration, J will start from 1 to n, right? So this means the innermost loop is repeated for n times, okay? So when I is 1, J start from I plus 1, so that means J from 2 to n. So this means the innermost loop, the comparison is done for n minus 1 times, so on and so forth. All right. So in the end, the total will be everything here add up together. It should be something like that. Okay, so yeah. Oh, I didn't realize I have asked you this question. So right, that is the answer. Okay, so since this answer is required, so I'm going to fill out the detail here, right? So for the last iteration, I will be n minus 1. So the last element, second last element, j will be n from I plus 1 to right. So that is from n to n. So that in turn means that the innermost loop, which is this statement, is executed just for one time. But overall, right, so we have a nested for loop. So overall, how many times this part that I circle is repeated? So that is t sub n. So we collect everything here, add them together. So that is 1 plus 2 plus 3 plus all the way to n. Okay. Yeah. Okay. So that is right based on the formula, right? And this one, right? We drop the simplify to n over 2, right? Drop the lower order term, drop the coefficient, constant coefficient. We get that the running time is quadratic in n. Right, so part 3, how to apply divide and conquer paradigm to solve the problem. Okay, so this, we kind of have very similar problems. So, and I refer you to look at the add up to k problem, add up to 100 problem in quiz 3. So if you already solved that problem without any concern, you can skip this part, but I'm going to go over this for the rest of the class. I probably don't have enough space to go through this, so maybe this is a time for me to take a pause and resume afterwards. Okay.